Hi there, everyone. My name is Mike Merrill. I'm a postdoc at Stanford, and I'm here today to talk about Terminal Bench, which is our hard benchmark for language models as agents in realistic terminal environments. So just to motivate this a little bit, we all know an engineer who operates something like this. Well, you're clicking through the AWS interface, trying to figure out how to launch your EC2 instance, looking at your security groups, trying to mount a volume. They just know the command to launch this thing in an instant. And as an aside, I think that this is what a lot of agent interactions are going to look like in the future. I don't really believe in this GUI way of doing things, but I can talk more about that later during questions if you're interested. But I do think it's worth asking, like, what if AI agents worked like our best engineers? To some extent, they already do. So if you look back over the last few weeks or months, you've seen this proliferation of agents that operate inside the command line. You've got your Claude Code from Anthropic, your Codex CLI, your Gemini CLI, even what we might not think of as CLI agents often interact with compute through bash commands. So you've probably seen Cursor write bash commands to do things like edit scripts or run Python commands. And then even these more personal assistant brand of agents also heavily use bash commands. So if you launch a Devon or a Manus instance, you'll see it interact with computers through the bash shell. And this shouldn't be really all that surprising, right? The terminal, first of all, is text-based, so it's the modality that still works best with language models. It's also highly powerful. You know, we hear these legends about these super cracked software engineers who never leave Vim. And if we give computers to language models in the same way, we open up this whole realm of possibilities for how we can interact between the two. And the terminal is highly valuable. It's not just used by software engineers, but it's used by systems administrators and scientists to do real work in the world. So it's this incredibly, I think, relevant point of contact when we think about automating work. And we're not the only people who think this. Guillermo Rauch, the founder and CEO of Cursor, tweeted a few weeks ago that it's 2025 and some of the most impactful products in the world are CLIs. Coding agents love running CLIs. ChatGPT solves problems by writing scripts in virtual environments where it orchestrates a CLI. And really what I'm trying to get to here is that the CLI in the terminal is this great environment for interacting and for allowing AIs to take control of compute resources. But how do we know that terminal agents are ready for production environments? Are they ready? I don't think so. And that's because of commands like this. You know, it's very easy to imagine situations where you wouldn't want an AI agent to have this level of control over your environment. And so that's why we built Terminal Bench, is to help us understand what the limits and the capabilities of AI agents inside terminals are. And so Terminal Bench is really comprised of two parts, which I'll break down for you now separately. The first is the Terminal Bench Harness, which is our open source framework for building and evaluating agents in the command line. And the second part is Terminal Bench Core, which is our data set of, it says 90 here, it's closer to 120, handcrafted expert level environments and tasks that showcase what agents can and can't do when you put them in these situations. So I'll start off by talking a little bit about the Terminal Bench Harness. If you've ever tried to implement an agent eval on your agent or your model, you know that it's a real pain. Every benchmark comes with its own harness and repo that you have to configure and install. Every agent has different installation requirements, and every environment might be configured entirely differently. And so we try to standardize this a little bit through the Terminal Bench Harness. The Terminal Bench Harness allows you to evaluate state-of-the-art agents like Claude Code, Goose, Codex, OpenHands, some of the names that you've heard during the talks earlier here today. And it's also worry-free. We've sandboxed it, meaning that you don't have to worry nearly as much about these RF commands that I mentioned earlier. And Terminal Bench, I also want to highlight, is highly adaptable. So it comes standard with evals like SweBench in addition to the benchmarks that we've implemented for our own testing. So what I'm getting at here is that this harness is a great way of testing your agents, testing your models, and letting us do all the hard work for you instead of spending engineering time on getting your own evals up and running. So that's the harness, which we built to evaluate terminal agents and agents more broadly. I also want to highlight Terminal Bench Core, which, as I mentioned, is now about 120 tasks that were written by humans. Each of these tasks comes with a verified ground truth solution, so we know that the task is possible, and a set of test cases which were also written by humans to verify whether or not the environment is completed and that it's in the state that we inspect. And in addition, each comes with its own Dockerized environment. So some examples of what we're interested in include compiling exotic code from source, scientific computing workflows, dependency management, the dreaded broken Python environment, reinstalling CUDA, as many of us I'm sure have done at some point, and end-to-end processing pipelines. So we're interested in not just these types of tasks that involve system administration, what you might traditionally think of as being a terminal-based project, but also really anything that can be done on a computer that can also be done through a terminal interface. Our principles with this are that we want to make it hard. I should say this actually is not the right soda anymore. It's 50%, but I'm still going to call it unsaturated. We've also built it to be incredibly real. So each of our tasks is based off of a contribution from a PhD level contributor. And we made it live. So it's versioned, but as model capabilities increase, we're going to continue to add new tasks and make it more difficult. In our testing prior to release, the best model completed only 35% of tasks. And then not long after, Anthropic, only 3 days after we release it, featured it on the model card and set a new state of the art. So we think this is a great benchmark, and it's been really great to see the broader community take this up. Also in open source world, Qwen3 Coder and Kimi K2 also evaluated on this in their model card. Just a handful of the things that we've noticed by building and evaluating on Terminal Bench. The first is that GPT 4.1 really, really likes using Nano, and will try to invoke it on almost any task. And it's also quite bad at writing JSON, although it insists that it's able to. And we also found that Goose, like any good senior software engineer, will often try to tell you what to do rather than doing it itself. And it's been kind of fun to see some of these quirks of these agents as models come out in testing, and you'd expect to see more of this in the paper that we're planning on releasing in a few months. I've got an example here of one kind of interesting failure mode. So in this case, GPT 4.0, I believe, is being asked to build the Linux kernel from source, and it's opened up a Vim terminal and gotten a little bit overambitious about what it can do, a Nano terminal, and it keeps on trying to exit, repeatedly spamming Control X again and again and again as it tries to get out of the environment. But it's sending things wrong, and it can't figure it out, and it can't recover. And so you see, these agents fall into these predictable loops where they get stuck, they don't really know how to fix themselves, and this is also something that we're interested in seeing improvement on. So, more broadly, our roadmap here is to continue to build hard tasks. We are an open source project, and if there's anything that you've struggled with in the past, in the terminal or on a computer more generally, we'd love to see that turned into a contribution to the project. I think it's a great opportunity to shape the frontier of these agents and models and make sure that the problems that you care about are also included in models in the future. We're working on building cloud deployments. Right now everything runs locally. That's something we'd like to fix. And we're also building RL training environments directly into the package as well. So we are interested in building this package where not only can anyone bring their own agent and run evaluations, but we can also generate rollouts inside of some of the environments that we've created. I just want to give a quick thanks to my team, my co-lead Alex Shaw, some of the many contributors on this project, as well as our advisors, Andy Konwinski and Ludwig Schmidt. And say, come join us. I think I'm very excited to be working on this project, and maybe some of you would be as well. Thanks. And can I take questions? Is that?
I was wondering, obviously everything is possible in a standard shell in principle, but in practice there's lots of little glitches, and that seems to be what holds human engineers back as well as LLMs. I was wondering to what extent, maybe it's not in scope for you, but it seems that a lot of the potential would be to simplify and rework the command line entirely to be a better command line for AI. And I was wondering, and then compare that. And I was wondering if you considered alternate shells, alternate command frameworks, and then doing tests between them and seeing if it's possible to have much better reliability.
Yeah, I think that this is something that we're very interested in. I mean, in general, it's my belief that we shouldn't treat any interface designed for a human as being the best one for a language model. That was kind of what I was getting to earlier with GUIs and why I think that it's just not the most efficient way to execute some of these things. I mean, we have seen some very common areas where these shells start to fall apart. In particular, manipulating interactive sessions is something that language models really struggle with, like file editing in Vim or Nano, as I showed here. And so, like, you can imagine building shells that more elegantly support some of these operations for language models, although it's not something that we've really looked into yet. But you know, I do think that a great deal of communication between language models and computers is going to be mediated through interfaces that look like this going forward. You know, you see these like computer use demos where a cursor is being dragged around on the screen and being used to book a flight or whatever, and like I just don't buy that. So I think that the shell is going to. I'm getting some thumbs up. Yeah, I think the shell is going to continue to be a very valuable place to explore. And if you have ideas about this, I'd be happy to talk about it as well. Sure.
All right, I think that's all the time we have, but thank you for the talk.
Thank you.